Okay, if there is no question, we will switch to the next talk. And let me announce that talk. This is on the topic of identification of sub-seismic natural fractures for potential carbonate reservoirs in thrust and fold belt tectonic zones of Pakistan through geochemical modeling techniques. The authors are Imran Khan, Naveed Ahmed, Iftikhar Ahmed, Khurram Shehzad, Awais, Kashif Shehzad, M. Noor Alam, Asim and Asif Israr, Shabir Ahmed. This talk will be presented by Imran Khan. May I request Imran, please?
Thank you, sir. Good evening, everyone. Today I'm going to present the topic identification of subseismic natural fractures for potential carbonate reservoirs in thrust and fold belt tectonic zones of Pakistan through geomechanical modeling, forward modeling techniques. The co-author in this paper with me is Naveed Ahmed, Iftikhar Ali, Kashif Shehzad, Noor Asim, Muhammad Awais, Khurram Shehzad, Shabir Ahmed, and Asif Israr. We are just working in Basin Study Exploration Research Department of UGTCL, and this work has been done by the Prospect Generation and Basin Study Exploration Research Department collectively for the identification of the fracture carbonate reservoir in one of our field. The content of my presentation is introduction to the study area, location of the study area, objective and data set, methodology which we have applied during this study, and then structure modeling and structure configuration of the study area, geomechanical modeling through elastic dislocation theory, and geomechanical modeling results verification with FMI logs, and then conclusion, recommendation, acknowledgement, and references. So for this, my first slide is this is my first slide, just showing that the rock just deform during the earthquake activities. So these deformation of the earth crust during the interseismic, co-seismic, and post-seismic activities deform the sedimentary strata and fold and thrusts. And during these deformations, the sedimentary strata have also some changes in their characteristics, in their properties, rock properties. So when we look into this figure, that during these deformation, the faults created due to the stresses. And when the stresses continue on the rocks, it suddenly discontinue at the boundaries. These boundaries are actually the fault planes. And these fault planes is defined the geomechanical modeling approach. We utilize these fault boundaries, these fault planes as a dislocation medium in the geomechanical modeling approach. If we look into this general figure, just illustrating before we going to our case study, this is a general overview of when and there is regional forces operate on the rocks, there is regional deformation, and when after regional deformation further stresses come, then it's broken into faults, the folds just broken into faults, and these fault perturbation further creates a deformation in the brittle crust. So this total strain we can then interpret from the seismic, convert into structural geological model, and then we convert this structural geological model into geomechanical model, and finally we identify the fracture corridor on this geomechanical model.